Hello, am I audible, guys? Yes, okay, cool. So, hi everyone, my name is Pradyumn Kejriwal, and today we are having the PCD of Leetcode Biweekly 150, and we'll discuss the problems A, B, and D. Before we start, I would like to tell you about our newly launched version 2 of CP31 sheet. So, as you can see, for all those who are not aware, this sheet encapsulates 31 handpicked problems in each rating from 800 to 1900, carefully chosen so that every problem teaches a unique idea. Our sheet has now been upgraded with a new interface, automatically syncing your progress directly from code forces, and a dedicated discussion section for each problem. Right? There is also a leaderboard of this sheet where you can find yourself and your friends, and you can compete among yourself that who solve more problems and all. Added to this, every week, 7 to 8 solutions, video solutions will be released. So no more wasting time on the wrong problems. The link to the sheet is in the description. All right, so let's get started with our first problem. Okay, so here we have um, the first problem, which says given an array of integers nums and an integer k, and an element nums of I is considered good if it is strictly greater than the elements at the indices I minus k and I plus k if they exist. If neither of the indices exist, nums I is still considered good. Return the sum of all good elements in the array. Okay, so the problem says that we have an array. Okay, we have an array of n numbers, let's say, like, okay, and it is called uh, nums. All right, so the problem says that we have an array of n integers and the ith element, which is ai. Ai is called good if ai is greater than a of I minus k and ai is greater than a of I plus k, right? And if like they don't exist, if either ai minus k or ai plus k don't exist, then we won't consider that inequality. Like basically it is by default true if suppose a of I minus k doesn't exist. Like suppose we add the first element and k is equal to 2, then definitely a of I minus k doesn't exist, right? But in that case we'll consider that okay, we have no problem, and we'll just check this condition, that a of I is greater than a of I plus 2. All right, and we have to determine the sum of all good elements in the array. Okay, so that is our problem here. Now this is actually just implementation. Like you can just iterate over the array, and for each element check that is it good or not. And to check that, you can simply just check these two conditions in order of one, right? So yeah, and like you can just iterate over the array and just check these two conditions. And actually, before checking, you also need to check that they exist or not. Like if I minus k doesn't exist, then you don't need to check, right? So what I did was first I wrote a condition for if I greater than k. Like if I is greater than or equal to k, then only I check inside. And then in here, I check that okay, if a of I, if it is less than or equal to a of I minus k, then we don't count ai, right? We want ai to be greater than a of I minus k. So in this case, we don't count ai. So I just set a flag equal to false. I have kept a flag, so I set flag equals to false. Okay. So this is for the first index, and for the like this is for a of I minus k. And if for a of I plus k, I'm writing that okay, if I plus k is less than a dot size, then what will happen? Like, then I have to check that, okay, if a of I is less than or equal to a of I plus k, then flag equals false. All right. And then at the end, if flag equals true, then I just add the element to my running sum. I have a variable for sum also. So at the top, I will create a variable for sum before the for loop, and in each iteration, if the flag is true, then I will add it to the sum, and otherwise I won't. So that is the implementation of this question. All right. So I'll share the summation. Like, I'll show you the code. And okay, so the code is right here. So first of all, I like change the name from nums to a so that I can type faster. Now I created a variable called sum. Int sum equals to 0. For int I equal to 0, I less than a dot size I plus plus. Okay. So bool flag equals to true. So for each iteration, first of all, I am setting a flag as true. Now I am checking both the I minus k and I plus k. Okay. So for I minus k, I'm checking that if I greater than equal to k, then if, like, basically if it exists, then I check that if ai less than equal to a of I minus k, then flag equals false. Now for I plus k, I check that I should be less than a dot size minus k. So if a of I minus so if a of I less than equal to a of I plus k, then flag equals false. And in the end, if both of these did not change our flag to false, then that means ai is greater than a of I minus k and ai is greater than a of I plus k. So if flag, then sum plus equals to ai. So for each I from 0 to n, I do this and then I just return sum finally. All right. So I hope it is clear. If anyone has a doubt, then they can ask right now. Like, any doubt in this problem or this code? Clear. Okay. So let's move on to the problem number B. Okay. So problem B is separate squares 1. Problem says that you are given a 2D integer array squares. Okay. Each squares of I is equal to xi, yi, li. Represents the coordinates of the bottom left point and the side length of a square parallel to the x-axis. So we have been given an array called squares, and each element is a square. It determines the bottom left corner's x coordinate, y coordinate, and the side length. And this side is parallel to x-axis. Find the minimum y coordinate of a horizontal line such that the total area of the squares above the line equals the total area of the squares below the line. Answers will 10 to the power minus 5 of the expressions will be accepted. So we have to, like, it is a decimal value. Squares may overlap. Overlapping areas should be counted multiple times. Okay. So, all right. So the question is, like, we have been given like a coordinate plane, right? A coordinate plane is there, and we have been given multiple squares. So let's say this is one square, this is another square, and so on. So let's say we have two squares, and we have to um, report the y coordinate of a line. So let's say this is the line, such that the total area below this line is equal to total area above this line. Okay. So that is our question, that we have to report the y coordinate of this line, right? So okay. Now, thinking about this, okay, let's see the test cases, the sample test cases. So one of the inputs is like this square is like this. One square is at 0 comma 0 and another one is at 2 comma 2, and both have side length equal to 1. So I'll draw this. One is at 0 comma 0 with side length 1, and another one is at 2 comma 2 with side length 1. right? Now if I draw a line, let's say I draw a line here, then above this line, area, total area is 1, right? And below this line also, total area is 1. So therefore this is one of the answers, but actually we have to report the minimum possible value of y, right? Basically if this y was at, let's say this is 1, right? So this, let's say this is 1.5, then 1.5 also satisfies the condition, but it is not the minimum, because at minimum we can actually draw here. If we draw the line here, then what will happen is, the area below the line, it is 1, and above the line also it is 1, and if we go even below, then it won't satisfy, right? Because if we go even below, then the area above will increase. Like let's say it is at 0.5, then the area above is 1.5 and area below is 0.5, right? So that's why the answer to this one is 1. Okay. So yeah, as actually, if you like think about it for some time, you can actually figure it out that, okay, let's say initially the line was at the bottom, all right? So let's say I check for x equal to, I mean y equal to 0. The line, this line is y equal to 0. So how much area will be above and how much area will be below? So below there will be 0 area, right? And above there will be like all the total area. The total area of the square will be above only. Below there won't be any area, and the above, and above it, all the area will be there, right? So that's what happens if y equal to 0. So definitely y equal to 0 is not the answer unless there are no squares. All right. So if there is at least one square, then y equal to 0 can't be the answer, because um, the areas are not equal. The areas are not equal, right? Now if I move this line above, okay. So let's say I move it to somewhere here. So I'll just make it a bit cleaner. So let's say I move this line to here, okay. Now the area below this line and the area above this line, what has happened to them? So basically the area below this line has increased, because initially it was 0, right? But now it is something. Let's say this line is at 0.5 or something, okay. So it is at 0.5, then now the area below this line is 0.5, right? That's the thing. And above this line it is 1.5. Okay, so it is increasing. Now if I move it even up, move it like even further, then the area below the line will increase. It will increase more. So if I move it here, then the area below this line is 1 and above this line also 1. Okay, so basically, as we can see that as we move this line above, the area actually is increasing. The area below the line is increasing, right? And we want that point where the area above the line and area below the line is equal. So if we know the total area, suppose total area is A, then basically what we want that the area below the line is equal to A by 2, right? Because the remaining area, which is A by 2, will be above. So they will be equal. A by 2 is equal to A by 2, right? So we want the position of that line such that the area below and above are both equal to A by 2. So how will you do that? Like basically, as you can see that if I move the line above, then area increases, right? So if I increase the y, uh, if I increase the y, then area under or area below also increases. All right. So we can actually observe this and use this fact that it is increasing. So it is actually monotonic, right? It is monotonic. So we can actually use binary search on answer. Like what we can do is we can check for a certain value of y. Okay. Basically, if we check for a certain value of y, that how much area is below it. So let's say I check for y equal to 0.7, that how much area is below it. Then I will know that okay, 0.7 area is below it and 1.3 area is above it. Actually 1.3 is not required. Basically we'll check that how much is below. Okay, so this much is below, and since this is less than a by 2, here a is 2, right? The total area is 2. So since this is less than a by 2, which is less than 1, then what we can just do is, we know that our answer will be above 0.7. Like the current y, our answer will be above that. So that's what we know. So we can actually do binary search on this. That initially we start with, like, I personally took 0 and 2e9, like the lower bound as 0. Like the answer can be, okay, actually the answer can't be 0, but I just took as a loose bound that the minimum is 0 and the maximum is 2e9. Why I took 2e9 I will explain later, but now what you just do is, you just iterate. Okay, like you will just do binary search on this, and let's say 0 and 2e9, the mid is 1e9, right? Mid is 1e9, so you will check for 1e9. And actually this diagram is very misleading. Just a minute. Yeah, so suppose this is 2e9, okay, and this is 0, so I'll check for 1e9. Suppose this is 1e9, and I'll calculate that, okay, how much area is there below this line. All right, and I know that there is 2 area here, so that definitely our answer is below 1e9. So what I'll do is, I'll set high equal to 1e9, and low is currently 0. So again our new mid will be 5e8. So I'll check for 5e8 and so on. So this is typical binary search, right? And we can do that. But actually some people might not know this. This is actually the answer is in decimal, right? So we actually need to do on decimal. So see, initially, like if you are doing out integers, let's say your answer is an integer, then what you do, you just write while low is less than high, right? That means while your search space, basically, let's say your search space is this, then you choose the mid, and then you reduce the search space to half. Now this is your search space, so you will search till your search space becomes 1, like it has only one possible answer. So you will search till low is less than high. Like as soon as low becomes equal to high, then you break, right? That's what you do in integer binary search. But in decimal, what you can actually do is, you have a tolerance level, right? So basically, see, what does low and high mean? Low and high actually means that your answer is in between low, like your actual answer, the actual answer is actually greater than or equal to low, and is actually less than or equal to high, right? And if we are working with integers, let's say the answer is integer, then if suppose low becomes equal to 5 and high becomes equal to 5, then you can comment that okay, answer is equal to 5, right? But while binary searching in decimals, you never actually reach to a particular answer, because let's say initially you have a range as 0 to 2e9, right? Then the range becomes 0 to 1e9, it becomes half, then it becomes 0 to 5e8, and so on. Like it will convert to some value, let's say 1 to 2, then it will become, let's say 1 to 1.5, then let's say 1.25 to 1.5, and so on. So the interval length actually decreases, and it becomes half after every iteration, but it never actually converges to one particular number, because between any two real numbers, like between any two real numbers a and b, there are infinite numbers, right? So even if you decrease the length by half every time, you will never reach a single number. But here, since you are working in decimals, they have given you a tolerance. What is tolerance? That any answer which is within 10 raised to the power minus 5 of the actual answer will be accepted. That means that if your answer, the if your error is actually less than 10 to the power minus 5, then it is correct. So what we can actually do is, we know that uh, after the nth iteration, if we have low and high as our values, then answer lies between low and high, right. So if our this range, like the active range that we have, let's say this is the number line, and now we have low equal to this and high equals to this. So this is our active range right now. That answer can be between here. So if it is small enough, like if this range is small enough, then can't we say that our answer will definitely be in the tolerance level? Like, what I am trying to say is that suppose uh, the answer is somewhere between high and low, right? So let's say the answer is somewhere here. Then even if you answer, like even if you just print low, let's say you just see out low or return low, whatever. Like in lead code, we have return. So if you return low, then what is the maximum error that you can get? Like in the worst case, it can happen that the actual answer is very far from low. Like it can be at max here, but we know that it is between this range, right? Low to high. So we can just iterate in, like we can just iterate till this range is small enough. Like at every iteration, it is getting halved, right? So we can just iterate till this range is small enough, so that even if the answer is here and we print low, the error is still less than or equal to 10 raised to the power minus 5, right? So that means that we need to iterate till the length is not less than 10 to the power minus 5. So we'll just do that while high minus low is greater than or equal to 10 raised to the power minus 5. Till then, we will keep doing binary search. Like mid is equal to high plus low by 2, and so on. Like, and then we'll check, and then we'll update the high or we'll update the low. So after every iteration, it will reduce to half, right? So that's how we do binary search on decimals, and that's the logic. Like why we do this. Okay, and so okay, the only thing that remains is that how do I calculate the area? Like for a particular mid, how do I calculate that how much area is below the mid? So how do we calculate that? We can actually, that is pretty easy. Like you can just iterate over all these squares. Okay. So let's say you have a line and this is a square. So there can be three cases, right? There can be a case where a square is completely below this line. So let's say this is y equal to some mid. Okay. Suppose the square is completely below this line, or it can be that square intersects the line, or it can be that square is completely above the line. So in all of these three cases, you can actually calculate the area below the line. Like it is pretty easy to calculate the area below the line. So let's say the side length is c. Okay. Then in this case, it is just c square. The area below the complete area is below y equal to mid, right? So the area is c square. In this case, what will you do? In this case, we want this area, right? So this area is actually equal to, let's say this coordinate is x comma y, x naught comma y naught, let's say. Then actually this length is mid minus y naught. So your area will become mid minus y naught into the side length c, right? This side length is c. So this rectangle's ka area is mid minus y naught into c, right? And if the square is completely above, then the area is 0. The area below the line is 0. So that's how you can just calculate the area below the line. And if the area that you calculated, if that area is less than or equal to, okay, wait. Now, actually, we want the minimum possible y, right? So let's say that the area is greater than total by 2. Like the currently whatever we have, suppose this line, this niche wala area is greater than total by 2. Then what we'll do is we have to like decrease. We have to decrease the y, right? So what we'll do is um, our answer lies below this. So high equals to mid, right? Uh, so this is the if this is the case, then if area is equal to total by 2, then what do we do is, okay, this is the real question, that what do we do in this case? If area is equal to total by 2, then what do we do? Do we uh, okay, so someone, if you want to tell. Someone says return answer. No, that is not correct, because um, if there are multiple values where area is equal to total by 2, then you need to return the minimum possible y, right? So let's say in this test case, the answer is 1, right? But if mid is suppose 1.5, if this mid is 1.5 and you check that area is 1, okay, this is 1 1, so you return 1.5, but that is wrong. Okay, trace minimum. Okay, someone says said the correct answer, high equals to mid. Yeah, actually, yeah, basically high equal to mid works because, see, what we can do is high equals to mid. Why? Because your answer cannot be more than this. See, in this case, why did we do high equal to mid? Because we want to go down, right? Like basically, the answer cannot be more than the current mid, because area will definitely increase. So that's why we set high equal to mid. Now in this case also, the answer can be either this, like basically we are at here, right? And the above area is equal to the lower area. So the answer can be equal to this, but it can be also less than this. But we know that it cannot be greater than this. It cannot be greater than this because we want the minimum value of y, which satisfies the condition. So that's my point, that if we have both areas equal, then your answer cannot be more than this, because we have a possible answer like here, like if at y equals to 1.5 you are getting 1 and 1 area, then definitely y equals to 2 is wrong answer, because even if you get equal area at y equal to 2, you have a better answer at y equal to 1.5. So therefore the answer cannot be greater than 1.5. So therefore you will just set high equals to 1.5. All right, so yeah, that's what you do. If it is equal to total by 2, then high equals to mid. And if area is less than total by 2, then what do? You will just do low equals to mid. Why? Because the answer has to be greater than this, because we want to increase the area under the line, right? All right. So I hope it is clear to all, like the logic of binary search. And yeah, why did I take 2e9 as my upper bound? Because the constraints were like 1e9, 1e9. So the coordinates can be from 0 to 1e9, and the length also can be up to 1e9, right? So the highest point of any square can be up to 2e9. Like, let's say we have a square which starts at 1e9 comma 1e9, and its length is also 1e9. Then the highest point that the square will have will be at 2e9 coordinate. So definitely the answer cannot be more than that, right? So therefore I put the like I put the high as, initially I put the low as 0 and high equals to 2e9, and then I do minus search on this until high minus low, like while high minus low is greater than or equal to 10 to the power minus 5. Okay, so this is my logic. And okay, what is the time velocity of this? The time complexity can be calculated very easily. So basically, how many times are we doing the binary search? So initially range is 0 to 1e9, right? 0 to 2e9, and at each iteration it is getting halved. So let's say if initially the range length is L, then after the first iteration it becomes L by 2, then it becomes L by 4, then it becomes L by 8, and so on. So we actually want, after the ith iteration, it becomes L upon 2 raised to power I, right? And we want that this value is less than or equal to 10 raised to power minus 5, our tolerance level. So this gives us 2 raised to power I is greater than or equal to 10 raised to power 5 into L, where L is the initial length. So 2e, which is 2e9. So I is equal to log of 10 raised to power 5 into 2 into 10 raised to power 9. So which is just log 2 into 10 raised to power 14. And this is approximately like, I think around 40 to 50, like approximately this value. All right. So this is the number of iterations that we will need. This many iterations we will need, and in each iteration we are calculating the area, right? We are calculating the area under the line, which is like O of n, O of number of squares, right? So the total time velocity is just n, like order of n into log 2e14. All right. So this should actually pass, like since the constraints on n are 5e4, so it should pass. All right. So I think it should be clear now. Does anyone have a doubt in the logic? Can we form an equation? What equation do you mean? Why not high equals to max of y1 comma y2? Um, what is y1 y2 here? I don't quite understand your question. What is y1 y2 and where exactly are you talking about? Is there a way to do it in O of n? In O of n, I don't think so. Like, I don't like right now. I can't really think of any O of n solutions. The best I can think of is binary search, which is n log AI, like, or n log 2e14. I can't think of anything better than that. But technically speaking, this is also O of n because this is just constant. But okay, that is just technicality. Could you please use double and in int increment concept? I actually don't know what that is. Uh, Actually, we won't be discussing the third one, like separate squares too. We won't be discussing right now. We'll discuss the fourth problem, shortest matching substring. Okay. Yeah. So I'll show you the code. Just a minute. All right. So the code is something like we have separate squares this function, and I set low equals to 0, high equals to 2e9. So while high minus low is greater than 1e5, like I use absolute for no reason. Actually, it is not necessary. Double mid equals to low plus high by 2. So the mid is low plus high by 2. And then we calculate the area and the total area. So this area variable stores the total area under the line, and TOT variable stores the total area, like the total area. Okay. It doesn't depend on where the line is. Okay. So for I iterate over the squares, like over the squares array, I iterate. And there are three cases that if the line is less than or equal to x1, x of 1 means y. So if it is less than or equal to the bottom left corner, so that means that it is the third case. Like the whole area, the whole square is above the line. Okay. Yeah, these three cases. So the third case where the bottom left y is greater than mid, then that means that the area is 0. So I don't increment area, I just increment the total area. So x2 into x2. Okay. And I used typecasting here because in int type, x2 into x2 might overflow. Like x2 can be up to 1 in 9, right? So we cannot multiply 1 in 9 into 1 in 9 in integers. So I just typecasted it. Okay. Else if mid is less than or equal to x1 plus x2, x1 is y and the x2 is side length. So if mid is less than or equal to y plus side length, which is the top y. So the bottom y is y naught and the top y is y naught plus L, right? So if it is less than or equal to y naught plus L, then that means the second case is there. So in that case, area plus equals x2 into mid minus x1. So length into mid minus y, right? And total plus equals length into length, the total area. And otherwise, the third case, that means the whole square is below. So area plus equals to x2 into x2 and total plus equals x2 into x2, right? And in the end, if area is less than total by 2, then what we do, low equals to mid, right? If area is less than total by 2, then we do low equals to mid, and otherwise we do high equals to mid, right? This is the case here. And in the end, when we are out of this while loop, that means that our interval is of length less than 1 e minus 5. Like our tolerance is the length is less than the tolerance, so we can just return any number between that interval. So I just return low. You can return any number between the interval and it will pass. I return low. Why is high 2e9? Um, like you can okay, you cannot make high 1e9 actually, because it will fail. Why? Okay, wait. It is because, let's say there's one square which is at the height of 1e9, like the bottom left coordinate. This y is equal to 1e9, and the side length is also 1e9. So in this case, the answer will be this, right? 1.5 into 10 raised to power 9. But if you are taking high equals to 1e9, then you will get the answer as 1e9. So that is wrong. I will not be discussing the third one because I was not able to solve it. Actually, like, I know the logic, but it is not very concrete. Like, this problem is actually very tough for, like, as compared to the other lead code hard problems. This is pretty tough. So right now I won't be discussing it. We'll be discussing the fourth one. Actually, the fourth one is pretty easy, like very much easier than the third one. The third one has like sweep line algorithm, segment tree, coordinate compression, and like many other things. They are used. Okay, so yeah, we'll move on to the fourth question. All right. So the problem is, you are given a string S and a pattern string P, where P contains exactly two star characters. The star in P matches any sequence of 0 or more characters. Return the length of the shortest substring in S that matches P. If there is no such substring, return -1. Substring is, you know what a substring is, okay? So yeah, it is, the question is of just pattern matching. Like, if you might have done something like this already. Like, basically, have you guys done this problem that you have been given a string S and a string T? So find all occurrences of T as a substring in S. Like all the positions at which T occurs. So for example, if you have ABC, AB, ABC, this is S, suppose, and T is equal to AB, then you are supposed to return this 0, 1, 2, 3, 3, and 5. So you are supposed to return 0, 3, and 5, because this AB occurs at 0, at 3, and at 5. So have you guys uh, done this problem? Diwakar, I will try to read your approach, and if I understand it, then I'll tell you. But before that, I'll explain the problem. Okay. So, guys, have you done this problem that we have S and we have T, and we have to find all the occurrences of S in all the occurrences of T in S as a substring of S. Dijkstra. So I can't really understand how you are using Dijkstra. Actually, this problem is actually standard application of the KMP algorithm. Like, not the lead code problem. This one is like, I'll move on to it, but first I'll tell you about this problem, that find all the occurrences of T in S. So actually, this problem is standard problem of KMP algorithm. Okay. So what is KMP algorithm? KMP stands for Nuth Morris Pratt. Like these are three names of some computer scientist. Sorry, Nuth Morris Pratt algorithm, and basically it is actually very powerful algorithm, and we can solve many string problems using it. Like it is basically a string algorithm. Okay, so this problem can be actually solved in O of m plus n using KMP algorithm. Like of course, O of m into n solution is obvious, right? You can just iterate over all the positions and check that is that position a starting index or not. So that will take O of n into m time. But it can be done in O of m plus n using KMP algorithm. So if you guys don't know that algorithm, then I highly recommend you to study it from some online resources or even TLE's content. Um, so this algorithm can be actually used to solve this problem, that find all the occurrences of a string t as a substring of string s. Okay. Yeah, in GFG also it is available, so you can check it out there. And okay, so actually I won't be able to explain this algorithm right now, but basically I'll use this problem as a black box. Okay. Like basically I'll assume that we have a function which returns all the occurrences. Like if I there's a function, okay, there's a function called solve, and it returns, like it takes s and t, and it will return a vector of int, and it will return that what are the occurrences of t in s, like exactly where does it occur. Okay, so that's what it will return. So I'll use this function as a black box. Like I can't tell you right now that how this function works, but I'll actually this is a very standard algorithm. Like it will, you can find this like at many places. So I'll use it as a black box, and then I'll explain that how to solve this problem using this function as a black box. Okay, I can't explain that how this function works exactly, but I'll explain that how do you solve this problem if you have this function. And the code that I like this black box code I took from somewhere. Okay, um so I actually searched for find all occurrences of a substring string. So I got this article, and from here we have the standard code. So this is the function that I used. Okay, and I'll link this. I'll send the submission link also, so you can check it out there. So alright. So alright. Um, if we have this function, then what can we do? So now that you know the pretext, I'll actually now explain the question also. So the problem actually says that okay, we have two substrings p and s. We have two strings. Sorry, we have two strings s and p. S is the string, like both are strings, and this p is a pattern string. Pattern string means that we need to find this p in s, like all the occurrence, like we have to find this p somehow. Okay, so it is kind of similar to s and t only, that we have to find all the occurrences of t as a substring of s, right? So we have to find some occurrence of p in s. But the thing is that p actually has some non-determinant also. Like see, t actually has all the letters, right? T has only letters. Let's say AB, and S has ABC, ABC, ABC. So you can just easily find out using KMP that AB, and AB are occurring at 0, 3, and 5. So it is pretty easy. But the twist in this question is that P contains some special character also. Like it contains a star. Like P contains letters and also a star character. Like this one also it contains. And what does this mean? It actually means that Like this star can be equal to anything. Like you can claim that this star is actually A, and Leetcode will agree. Like you can claim anything that this star is. Let's say you call it AB also. You can call it AB as well. So it doesn't matter. This star can be equal to anything. So give an example. If I give an example, let's say we have this. Okay, AB, AA, CB, AE, CE, BC. So this is S, and P is BA star C star CE. So what they are saying is that this string right here, BA, CE, BCE, is matching with P. Like just like uh, this substring AB is matching with AB, they are saying that this BAE, CE, BCE is matching with this string right here. And why? Because okay, BA matches. Now we have a star here and we have E here. So they are claiming that this star is an E. So okay, no problem. So assuming that the star is an E, okay. Then we have a C, we have a C. Then we have a star, and here we have EB. Like this EB, they are saying that this star matches with this EB. And then finally this CE matches with the CE. Okay. So that's why this BAE CE matches with this BA star C star CE. So we can make this star as anything. We can even make it empty also. Like we don't care. Um, like maybe this example. Yeah. So in this fourth test case, we have ADLOGI, and this ADLOGI. They are saying that this ADLOGI matches with this P. But you will say that where is the star gone? Then actually you can also assume star is an empty character. Like they don't care. Star can be anything. Star can be empty character. Star can be just one character, and star can be a whole string as string also. Okay, so that is flexibility that we have. So here we print the answer as ADLOGI. So the output is 6. Actually, we need to print the shortest substring of S, which matches with P. Okay, like that is the question. The question is return the length of shortest substring in S that matches with P. Okay. So in this case, actually you could have also taken the whole word as well. Mad logic. You can take the whole word as well. But yeah, so it matches also. So like if you assume that this star is M and this star is C, then it is satisfied. But it is not the smallest. So you want the smallest possible substring that which matches with P. So ADLOGI matches with P because you can assume the star as empty. Okay. So in the example one, actually you cannot assume this star is empty. You cannot assume this as empty because then that string is not there in S. Like there is no such string in S which matches with empty character. Like if we consider this as empty, then there is no string which matches. Okay, so that's why we have to assume that this star is um, E and this star is EB. Okay, so that's why the length becomes 8. We are reporting this as the answer. So this has 8 characters, and that's why the answer is 8. Now in this example, there is no substring which matches. So the CC star BAA star ADB, there is no substring which matches with this. Okay, so that's why the output is -1. Like we have to print -1 if there is no substring with matches. And let's say this example, star star. So if you consider the empty substring of this S, like one substring of this is A and one is empty as well, right? So you can also consider empty substring, and that actually matches with the star star because you can consider both the stars as empty. So the answer is length of the empty substring, which is 0, right? So that's why you can do this. That's how you can do this. Okay. All right. So the question is now clear, I think, that you can match this star star with anything. any sequence of 0 or more characters. Okay. So now, how do we actually solve it? So there's one thing, that this P contains exactly two star characters. This is one very important information to us, that this P contains exactly two star characters. So what does that mean? So let's see that what does that mean. Okay. So our P looks like there are two stars, right? There is one star here and one star here, and then there are some characters here, some characters here, and some characters here, right? Now it may be that this is empty, or maybe this is empty. Like, that is also possible. Like this bracket, sorry, this dash has either some characters or it is empty. Okay, so that's what P will look like. That there is some characters here, then a star here, then some characters here or no characters here, then star here, then some or no characters here, right? That's how P is supposed to be looking, right? And we need that this matches with S, or a substring with S, it matches. So what does it mean that it matches? It matches, like, basically, um see, let's say we have that the string is S, right? In S we need to find a substring that matches, right? We have been given S, and we need to find a substring of S which matches with P. So what we can, let's say that that substring is T. Okay, that substring is T. So I'll just give an example. Okay, um I'll just take this example and I'll explain using that. So here P is BA star C. So this is BA, this is star, this is C, this is CE. Okay. So, and here we have T as, T is actually equal to BAE, BAE, CE, uh, CEB, CE. Okay. So I'll just draw some lines for visualization. Wait. Just a minute. Yeah. So I'll draw these lines. So okay, we have this first part of the string P, the second part of the string P, and the third part of the string P, right? So the first part is here, the second part is here, and the third part is here. And in between, whatever there is, we don't mind, because the star will get matched with that, right? So just analyzing and just think about it for a second, that this P looks like a star is between, and before the star there is the string 1, between the two stars there is the string 2, and between the, after the third star, after the second star, there is a string 3, and the first string has to be a part of T. Then there is some characters, maybe empty also, it may be empty also. Then we have some second character, like second substring as a substring, and then we have some characters, and then we have this CE. Okay. So in the context of the whole string, let's say we had a long string. Okay, we had a very long string. So let's say this is a string. So basically, let's say there are some BAs there. There is a BA here, there is a BA here, there is a C here, there is also a C here, and let's say there is some Cs. Let's say there is a CE here and a CE here. So now what we want is BA, C, and CE, right? BA, C, and C. And actually, you can find this efficiently, right? You can find this information very efficiently using that function that I told you. That solve function, it will return the positions where the all of these three substring are there. So all the positions of BA, all the positions of C and of CE, it will return, right? So we have some BA here, we have CE here, we also have C here, some C, CA, CE, uh, and BA also. And what we want is, we want a BA, we want a C, and we want a CE. Okay, so that's what we want. So let's say if we want, if we take this BA, then let's say we take this C, then actually we cannot take the C. We cannot take this C because already this C is occupied, and we want in this order only. Like the order matters. So we can't have like, we take this BA, then this C, and then this CE, because the order matters. What we can have is this BA, this C, and this C. So this is one of the possible answers. And let's say there is some CE here as well. So this is one possible answer. Another possible answer is BA, C, and CE. So this is also one possible answer. And what do I mean by possible answer? That okay, you can actually just report this substring right here, because it has a BA in the starting, then it has some characters, because the star will match to those characters, and we don't have any problem. And then we have a C, we have a C, then we have some characters here, right? And then we have a CE. So that's why this substring matches to this pattern P, right? So that's what just we just want, that we want a BA, then we want a C, and then we want a CE. And we know all the positions also. Like we know that all the BA, where do they occur. So let's say this BA occurs at 1. Like let's say this is the actual array. I'll make it more clearer. uh, let's say this E is right here. Okay, CE, and this E is also here, right? So I'll just number this 0, 1, 2, 3, 4, 5, 6, 7, sorry, 8, 9. Okay, so using the solve function, like this KMP algorithm, we can find out that okay, where do BAs lie, where do CEs lie, and where does C lie. So where do all the BAs lie? So BA starts at, one of the BA starts as 1. Okay, then it also starts at 10 also. Okay, so 1 comma 10, the function will give us in O of m plus n time, right? Then um, what about C? Where does C lie? C lies at 4, 6, 8, and 14. So we have 4, 6, 8, and 14. Okay, and CE, right? CE lies at here. So at 4 it lies, then at 8 it lies, and at 14 it lies. Okay, so that's what the function will give us. So this is what we have right now, and then we have to just choose one instance of each. So let's say we choose 1, 4, and 14. Like we want a BA, we want a C, and then we want a CE, in that order, right? In that particular order. So if we choose 1, then we choose this 4C, then we choose 14. So that works, right? Because that means that okay, I'm starting with this one, or let's say this one. Okay, and then I'm going till 14, or not really 14, 14 ke bhi aage, 15. I'm going till 15 to take the entire CE, right? So this substring works because we have a BA here. Sorry, we have a BA here. We have a C at 4, and we have a CE at 14, right? So it works. But the length is 15, which is too high. Like we can do better, right? We can do better. How? We can choose a previous CE. Like we can choose this CE also. So we would have BA, this C, and this CE. So this is the substring, and in this case the length is 9, right? Now notice that actually we cannot take, uh, if we take 1 4, then I actually cannot take this 4 again. Like we have to take from 5 onwards, because this 4 is occupied by this thing, right? So um that's what we have to do now, that we have to choose some of the instances such that they don't overlap also, they don't overlap and they are not very spread out. Like, see, what was the problem with this example, like this, what was the problem with this solution, like 1 6 and sorry 1 6 1 6 and 14. What was the problem? Because the problem was that it is too long, like it has 15 length, and we can do better. So basically the characters are too much spread out, so that's why it is the problem. So how do we actually solve this? We can solve this by, see, the condition for, like, see, let's say I choose A here, let's say I choose B here, and let's say I choose C here, basically the indices. So A can be equal to 1, for example, B can be equal to 6, and C can be equal to 8. Like, this is example. Okay, so let's say I choose A from here, B from here, and C from here. Okay, so what is the condition, that when can I choose these indices? The condition is that A should be less than B, should be less than C, right? That is one condition, that they cannot overlap. I mean, they have to be in that order only. Like, if I want BA first, then I want C, and then I want CE. That is my particular order. So I want that order. So A less than B less than C. But um, this is not sufficient condition. Like, I also have to ensure that they don't overlap. Like, here you cannot take 1 4 and 4, because 4 and 4 overlap, and actually 4 and 4 also overlap. But let's say we had something like, basically, let's say, let's take another example. Let's say we have BA, AB, and EC. Okay, and let's say BA we have, let's say string S looks like to and something, and B we have, then AB we have, and then EC we have, and dot. Okay, so one BA we have here, one BA we have here, and one AB we have here, one AB we have here. So I'll just number this: 0 1 2 3 4 5 6 7 8 9. So if we take the BA, so first we want to take BA, right? So if we take this BA, that means at index 3. So okay, BA, that index is 3, 5, right? And AB is at the index 4 and 6. So if I take the BA at 3, then actually I cannot even take the AB at 4 also. I cannot do this, because they overlap. Okay, so that's also what we have to take care of, that they should not overlap. Like, even though 3 is less than 4, the condition A less than B satisfies, but it is not sufficient because they overlap, so we cannot take them, right? So we have to take this BA, this AB, and this EC, because they don't overlap, we can take them. Okay, so we can take them. So this is one of the conditions, that A less than B less than C, but also we have to ensure that they don't overlap. And what does not overlap mean? It means that, okay, um it means that, let's say the length of this A, like the first string, there's BA, the length is L1, and the length of second string is L2, and length of third string is L3. Okay, now let's say we took three indices, right? We took index A, We took this index A, index B, and index C. All right. So when will they overlap? So index A has L1, right? L1 string starts from here and goes till like length L1. The first string starts from A and goes till length L1. So where will it go up to? It will go up to starts at A, right? So A plus L1 minus 1. It will go till this index. So definitely B has to be greater than that. So B has to be greater than A plus L1 minus 1. So this is one condition. And the substring which starts at B, the L2 one. So it starts at B and has length L2. So it will go till B plus L2 minus 1, and that has to be less than C also, because we cannot let it overlap with C, right? So B plus L2 minus 1 should be less than C. So that means that C is greater than B plus L2 minus 1, right? So that's what we have to ensure, that we have to simply now the question boils down to that we have all the positions, like through that KNP function we have all the positions of those three strings, that BA, C, and CE. We have all three positions, and we just have to choose three indices. We have to choose three indices such that these two conditions, this first condition and this second condition, they both satisfy, right? And the total length, like the spread out what is, okay, let's compute the length as well. All right. So if we compute the length, how do we do that? Basically we start at A, right? The starting index is A, and what is the ending index? Ending index is like the third string starts at C and goes till L3 length, right? So the ending index is C plus L3 minus 1, right? So what we need to do is, so the length was, what is it? Length will just be C plus L3 minus A. Okay. So we need to select three indices A, B, and C such that this is satisfied, and we have to also ensure that this is the minimum possible. This is the length, right? We have to minimize the length of the substring. Okay. So yeah, the problem boils down to this, that we have certain indices in the string and we have to select. So how do we do that? Any ideas, guys? How do we achieve this aim, that we need to select three indices? That, okay, we have a list of indices 1, 10, 4, 6, 8, 14, and 4, 8, 14, and we have to select such that these two conditions are satisfied. So any ideas does anyone have about this one? We can actually solve it in O of n, right? We can solve it in O of n. So actually we can iterate over one of the indices. So let's say we iterate over A, right? Then we want that B is greater than A plus L minus 1. So we'll choose the first B that satisfies this property. And then we also want C greater than B plus L2 minus 1, right? So we'll choose the first C. Like out of all the possible C's, we choose the first B and the first C. So let's say we have the values of A are possible as this one. So these are the possible value of this. These are the possible values of A. Possible values of B are this, and possible values of C are this. So if we take the value of A as 1, then the value of B can be either 4, 6, 8 or 14. So obviously we'll take 4, right? And if we take B as 4, then we have to say take C as 8 or 14. So we'll take 8 because we want to minimize the spread. So this one, so if we take this one, then 4 and 8 are the optimal. Then if we take 10, what if we take 10? If we take 10, then we have to take 14 in this one, and then we cannot take anything in this one. Okay, so we can just iterate over all the elements of A. Matlab, from this array, in this array we can iterate, and then we can just use BS, like upper bound and lower bound, on these two arrays to find the first integer greater than what we want, right? So that's what we can do, that we can iterate over this first array, then we'll find the first element under the constraints from the second array, and again using that element we'll find the third element from this array using the constraints that I told you, that b greater than a plus l1 minus 1 and c greater than b plus l2 minus 1, right? That's what we can do. Actually, in my code, what I did was I iterated over this second array. Like I iterated over all the values of b. Okay, so I fixed the value of b, and then so basically we want a, b, and c, right? So I fixed the value of b, and I found a value of a the closest to b. That before b, the closest value a, and after b, the closest value c. And that's what I did using binary search only. That I did over all the values of b, and then I chose the closest one to the left of b. Actually, not the closest, like satisfying the constraint. Like we want this, right? A plus l1 minus 1 less than b. So we want a should be less than b minus l1 plus 1. So the first index, I mean the highest index satisfying this constraint, like that's what I found, that if I have a value of b, then I can find the closest value of a satisfying this constraint, and also I can find the lowest value of c, that is the closest value of c satisfying this constraint, both using binary search. And I will just do that, and I'll update the minimum, like I'll iterate over the entire array b, and I'll keep updating the minimum. All right. So yeah, that's what we can do in the problem number D. That you can just find out all the occurrences of those three strings, and you have to select three indices. So you can just iterate over one of them and then find the two of them greedily using binary search. Okay, and over all the possible values, you can just take the minimum. So yeah, that is the solution to this problem. And also have to handle some edge cases as well. That okay, what if this is empty? If this is empty, like let's say ba, instead of ba there was nothing here, let's say this was empty, then you don't need to find anything, you don't need to find the previous substring, you just need to find these two. So just find these two and do that, right? So it actually becomes easier, that instead of finding three things, you have to find two things. And let's say this one was empty, sorry, like instead of the first one, the second one is empty. Let's say this one is empty. Let something like BA star star CE. So the middle one is empty, right? So then you have to just find A and C such that A plus L1 minus 1 is less than C, and so on. So just handle the edge cases, and that's the solution. So I hope that it is clear to all. Does anyone have a doubt in the fourth problem, in this problem, like the logic part? I'll show you the code also in the in some time. But before that, does anyone have a doubt in the logic? Anyone? For question 2, high should be the maximum y coordinate of all square of any square. Yeah, that also works. Basically, you can just take y as whatever high value you want. Like it just has to be higher than any possible answer. Like the possible answer, it has to be greater than that, greater than equal to. So you can take the highest possible y, or you can take 1e9, or sorry 2e9, or you can take 2e18 as well. So of course the answer cannot be that big, but there is no problem in taking that big of a number. Like that's why I took 2e9. What you said also works. You said that maximum y coordinate, so that also works. Actually, that is the idea behind 2e9 as well. That the maximum y coordinate that can be is 2e9. So that's why I took 2e9. The thing is clear, but I'm still wondering how to handle the edge cases. Okay, so I'll show you the code for that. All right. So I'll show the code. Okay. Yeah. So handling edge cases also is pretty tough. So for that I got three wrong answers. But anyways, sorry. Yeah. So um, this is the code, and the first two functions are the template. Like I just copied from here, that they give us the occurrences, right? What I told you. So this function and this function, like this function actually returns that what are all the occurrences of the string pattern in the string str. Okay, so I'm using this function, and yeah, the code starts from here. Shortest matching substring, so string s and string p. Now what I do, I just decompose the string p into p1, p2, p3, right? Using the star delimiter. That I'm just decomposing this string p into the first part before the star, the between the stars, and after the star. Okay, and I think this is pretty straightforward. That I have a pointer I at 0. While pi is not equal to star, I just add it to p1 and I plus plus. Then while pi is not equal to star again, I'll add it to p2. Like we are between the two stars and I plus plus, and then till the end we'll add it to p3 and I plus plus. Right. So this snippet decomposes this p into p1, p2, p3. Okay. Now I just use this function here. That vector of int v1, v2, v3 is just all the occurrences of p1, p2, p3. So okay, v1, v2, and v3, and actually ignore these three lines. Like basically, I wanted to ensure that this function returns solid vector. It returns the answer in solid fashion. So I just added these three lines, but it is not necessary to like they do nothing. You can just delete them and it will be fine. Okay. So ignore these three lines, and this v1, v2, v3, I'm using like the solve function that I copied from this. So it returns the all the occurrences of p1, all the occurrences of p2, and occurrences of p3. The indices, the first index. All right. Now the edge cases, that if both p1 and p3 dots, like if they both are empty, then that is an edge case. Like what does that mean? That means that it is something like empty and star, then something like let's say abc, then star, and then empty. So the string is basically star abc star, or star something star. So the answer to this obviously is just abc. Like if we can find abc in s, then the answer is just 3. And otherwise, okay, so first of all, if p dot size is equal to 0, then return 0. Like that means that if the string is star star, like in this edge case, so basically if p1 dot size is equal to 0, p3 equal to 0, and p2 also equal to 0, then that means the string is just star star. Then the answer to this is just 0. 0 because empty string, right? Whatever the string s is, let's say abc, we can select the empty substring of this. Empty substring we can select, and the length is 0. So that's why return 0. Else if v2 dot size is not equal to 0, V2 is basically the occurrence of P2, right? The occurrence of P2 is stored in V2. So if V2 has some occurrence, then that means this ABC lies inside the string, right? In the string, inside the string S, there is some P2. So we'll just return ABC, like we'll return 3, or ABC dot size will return, right? And otherwise, P2 doesn't have the occurrence of, sorry, S doesn't have the occurrence of P2, so we return -1, right? So this is one edge case that if both of them are equal to 0, okay. And also I had to, I'll explain this later, okay. Before explaining this, I'll explain the further part. Now I have int ans equal to int max, okay, because we want to minimize the answer, so I initialize it with the maximum value, okay. Now for auto x in v2, v2 is the middle one, right? So as I told you, I am iterating over the elements in the middle vector, okay. So I am iterating over this middle vector, and I am finding the closest a and closest c, right? So yeah, iterating over v2, okay. Now I am having a variable called sum. Sum is equal to p dot size. That means this sum is actually equal to the final length. This sum is the final length dot the final length that I get of the substring, right? Okay. So it is currently p dot size because I have to take at least p dot size, right? Now, if p1 dot size, that means if p1 is not empty, then we have to search for it, right? Before p2. So currently let the current index for p2 is x, so we have to search for p1 which is less than x minus l1, right? So I just do auto it is equal to upper bound v1 dot begin v1 dot end x minus p1 dot size, so x minus l1. So it will give the smallest integer greater than x minus l1, which is the index that I cannot take. So I'll just it minus minus. So if it is equal to v1 dot begin, then that means there is no index that is smaller than x minus p1 dot size. So I was not able to find any index of p1 which was not overlapping or which was not greater than this one. So I'll continue. Otherwise, I'll just do it minus minus and sum plus equals x minus star it. So x minus star it, what does it mean? So let's say we chose an index, right? We chose an index x for the middle string, right? So let's say the middle string is here. Now we are searching for the first string. So let's say the first string we found here. So this is it. Like it points here, or star it is this. So and this is x. So initially we had incremental sum by this length. So this is the length that currently is, and also we have to increment this one also. Like we want to count this length also in our substring. So this length is equal to x minus star it. Okay. So that's why sum plus equals x minus star it. So if p1 dot size, that is if p1 is not empty, then we just search for p1 before this x part. And if okay, so this is for p1, and if p3 is not empty, then what do? We search for p3 after this x, like the first index after this x, or the first index after this x plus l2. So x plus l2 is this one, and we want to find out the first index after x plus l2, right? So I'm using lower bound v3 dot begin v3 dot end x plus l2, right? Now if it is equal to v3 dot end, that means that it is not able to find any instance of v3. Then continue. Continue means that this value of x is not valid because we were not able to find the instance of p3, right? And otherwise, like if we were able to find that, okay, let's say we found this it, then we need to add the length. So currently we have added this part, right? So we need to add this part, and like whatever the string goes. So it starts from here, right? The third string starts from here and ends at it plus p dot size, right? So we need to add this much length, and this is equal to star it plus p3 dot size minus x minus p2 dot size. So I subtract this index from here. So that is the length of the remaining portion. So yeah, we search for p1 and p3, and then so basically at the end we have the total length, that if we take x as the middle element, then what is the minimum length. So I'll just take min with the answer. Ans equals min of ans comma sum. So yeah, that is the thing. But also there's one edge case, that if p2 is empty, like if p2 is empty, then v2 will be empty. Like this function, in the function if we give it empty string, then it will return an empty vector. Okay, like I tested that thing, so it will return an empty vector. So if p2 is empty, then I just push back 0 to s dot size. Like in the v2 vector, I just push all of them. Why? Because empty string can start from anywhere, right? Like we have to consider all of the positions for the middle element, because the middle one can start from anywhere. So to handle that edge case, I just push back all of the indices from 0 to s dot size. All right. So yeah, that was the implementation of this logic. And okay, in the end, if ans equals int max, that means that we were never able to do ans equal to mins of ans comma sum. That means that whatever x's we tried, we were not able to find the occurrence of a and c, the string a and c. So return -1. So there is no substring which matches. Otherwise, just return ans. Okay. So that's how you handle the edge cases, and that's how you implement the code. So I hope it is clear. Is it clear to all? Very clear. Okay, thank you. So if anyone has a doubt, then they can ask right now. Could you see my approach? Like if you run a test case, then you can dry run the test case on your code, and you will be able to see that, because I'm not able to currently understand your approach. And if I spend too much time on it, then it will waste others time. So like you can dry run the input on your code, or you can use debugger. So if you guys don't know, there is one site called online gdb. So in this you can actually paste your code, and you can compile it line by line. So it is not appearing to open. Okay, it is not opening right now, but you can use this site, and actually you can use it to run your code line by line. So actually it supports features like you can run it line by line, and after each execution you can see the variable value, like all of the variables you can see them at currently what is the value of them. So it is very easy to debug your code. So yeah. So anyone else has a problem in the code or something? What about question 3? Actually, I was not able to solve it like currently, so I can't discuss that. Maybe you can look at the solution, the editorial or something. But it is like pretty tough. like the third problem is actually very tough. If it had appeared on Code Forces, it would be like easily of 2100 or something. So yeah, that's why I can't discuss it right now. So if anyone has a doubt in question A, B, or D, then they can ask. So I'll wait for 2 minutes, and if no one has a doubt, then I'll end this stream. Where can we find return solutions? Um, no, no, not my return solution. Like I don't have a return solution for these problems. I was saying that you can go through the solutions of others, these solutions. Like whoever has the, like maybe you can read all of them and you can check it out. I'll send my codes in the description. Acha, okay, codes. So codes will be in the description after the stream ends. Okay. Okay. So I think everyone doesn't have, like, no one has a doubt. So I'll end the stream now. All right. Thanks everyone for joining, and all the best for the future, whatever. All right. Bye, guys.